Today, we're taking you on a journey through time. We'll explore the deep seas of millions of years ago and uncover ancient secrets that shed light on our current climate crisis. The limestone from Mercato San Severino in Italy holds a fascinating story that might help shape our future. Are you ready? Take a deep breath and dive in with us. The limestone in Mercato San Severino, Italy, carries evidence of a massive marine life extinction from millions of years ago. These findings provide crucial insights into how current ocean conditions might be affected by oxygen depletion and climate change. This ancient event, like similar ones in Earth's past, offers some of the best analogies for what could happen in the coming decades and centuries. Michael A. Kipp, an assistant professor of Earth and Climate Sciences at Duke University, is one of the study's co-authors. In a study published on June 24th in the Proceedings of the National Academy of Sciences, they measured the loss of oxygen in oceans that led to the extinction of marine species 183 million years ago. During the Jurassic period, when marine reptiles like ichthyosaurs and plesiosaurs roamed the seas, volcanic activity in what is now South Africa released an estimated 20,500 gigatons of carbon dioxide, CO2, over 500,000 years. This caused the oceans to warm and lose oxygen, leading to the suffocation and mass extinction of marine species. How did we discover the traces of this enormous catastrophe? The limestone in Mercato San Severino acts like a time capsule, preserving chemical traces from millions of years ago. By analyzing these chemical traces, scientists could determine how oxygen levels changed during that time. Michael A. Kipp and his team at Duke University used modern laboratory techniques to study these traces and discovered that oxygen was completely depleted in about 8% of the ancient seafloor. This discovery shows that an area 3 times the size of the United States experienced oxygen loss. Such extensive oxygen depletion spelled disaster for marine life. The vast amounts of carbon dioxide released by volcanic activity caused the oceans to warm and oxygen levels to drop, leading to the extinction of many marine species. Since the Industrial Revolution, human activities have released CO2 into the atmosphere equivalent to about 12% of the emissions during the Jurassic volcanism. However, today's rate of CO2 emissions is unprecedented. Michael A. Kipp explains, the rate of atmospheric CO2 release we see today has no historical counterpart, making it challenging to predict when another mass extinction might occur or how severe it could be. Scientists must study past events like these to understand the current climate crisis and prevent future disasters. But there are significant differences between the past and present. In the past, natural events like volcanic eruptions were slow and prolonged processes. Today, the amount and rate of CO2 released by human activities are much higher, making it difficult to predict how ecosystems and climate systems will respond to this rapid change. The massive oxygen loss during the Jurassic volcanism had a significant impact on marine ecosystems and biodiversity. The depletion of oxygen across vast areas of the seafloor caused many marine species to go extinct. This event offers important lessons about the future of today's marine ecosystems. Today, we are also witnessing a decline in oxygen levels in the oceans. Scientists are studying past events to understand the impacts of current oxygen loss on marine life. These studies can help predict the effects of future oxygen depletion and climate change on marine ecosystems. Renowned astrophysicist and scientist Michio Kaku emphasizes the importance of such scientific discoveries. Kaku states, studying past catastrophes is crucial for preventing future ones. Science has the power to shape the future by learning from the past. Similarly, famous biologist and environmentalist Jane Goodall highlights the significance of these studies. Goodall says, understanding the history of nature is vital for humanity. Events like these show how fragile nature can be. These studies also provide essential insights into preventive measures against future climate crises. Scientists stress the importance of reducing carbon emissions to prevent further oxygen depletion and protect marine ecosystems. Transitioning to renewable energy sources and using eco-friendly technologies are crucial steps in this process. Michael A. Kipp and his team underscore the importance of such research. We have quantified the marine oxygen loss during this event, which helps constrain our predictions for the future, says Kipp. Scientific studies like these can provide valuable information on measures to counteract climate change. Researchers used advanced analytical techniques to study the limestone from Mercato San Severino. By examining the chemical components of the limestone, they reconstructed the seawater conditions of that period. These analyses revealed the devastating impact of oxygen depletion on marine life. A similar process is happening today. Human activities release significant amounts of CO2 into the atmosphere, causing the oceans to warm and oxygen levels to drop. This threatens marine life and reduces biodiversity. By studying past events, scientists gain crucial insights into the current climate crisis. Scientists also provide important information on preventive measures against the climate crisis. To prevent further oxygen loss and protect marine ecosystems, we must reduce carbon emissions. Switching to renewable energy sources and adopting eco-friendly technologies are essential steps. This ancient extinction event serves as a critical warning about how today's ocean conditions might change in the future. Understanding the impact of human-made carbon emissions on marine life and preventing future disasters requires such research. Now, it's time to consider how we can shape our future based on this knowledge. Don't forget to subscribe to our channel and turn on notifications to stay updated with the latest in science and space. See you in the next video.